All right, today our last lesson in this unit on statistics is using measures of center and variability. That's the title for our lesson. So in your table of contents, write the title of the lesson, using measures of center and variability. Then flip to the next clean sheet of notebook paper in your spiral notebook and write the title and your essential question. How can I use measures of center and measures of variability to compare two sets of data? Hit pause, and when you're ready to move on, hit play. All right, copy this at the top. You don't need to copy the two graphs. We're just going to look at those in a second, but hit pause, copy the question, and copy the notes over here. What you are copying says, how can you use measure of center to compare data? It says, you can compare two data sets by comparing their individual values, but a quicker way to make a general comparison of two data sets is to compare their measures of center. And remember, we learned in our last lesson that measures of center include the mean and the median. Okay, so when we compare those two data sets, we're going to be finding their means and their medians, and that's going to help us compare the two data sets. Okay, so at the bottom we see two different classes. We have class M, we have class R. And so this example, they're talking about how many doodles were found in their notes. Okay, it doesn't say that here, but that's what this is about. If we counted the number of dots on each of the graphs, we would see that there are the same number of students in each class. Let's see, there's 1, 5, 8, 11, 12, 13, 14, 15, 16, 17, 18. So there's 20 students in this class. If we counted these dots, there would also be 20. Each little blue dot represents a person. And as we look, we see that they both have the same number of doodles most common. So the mode, we didn't define mode, but the mode would be the number that we have the most common, or the most often is 5. We have 5 people that had 5 doodles. We have 5 people that had 5 doodles. But if we calculated the mean, we would add up all the numbers divided by 20, because that's the number of people in the classes. So 0 plus 1 plus 1 plus 2 plus 2 and so on, divided by 20. We would get 4.05, whereas with class R, adding them all up and dividing by 20, we would get a mean of 5.1. So which class had more doodles? We would say class R, because the mean is just a little bit bigger. All right, looking at this example, you don't need to copy this, just look at it with me. It says, a book publisher is testing 2 versions of a new book. A random sample of people are given 30 minutes to read each version. What is the median of each sample? And then make a comparative inference based on the median values. So where do we find the median value from our box plot? We learned this in our last lesson, what each of these pieces of the box plot represents. Remember that, I'm just going to go ahead and review with you all the different parts. Right here we have our minimum, and right here we have our maximum. The two sides of the boxes are Q1 and Q3. The median is the line in the middle of the box. Okay, so when we look to find what that would be from the number line, it looks like the line is on 25. So I'm going to say the median is 25. For the second box plot, again, remember that the line inside the box of the box plot is the median. The median is 23. So we have to make a comparative inference now based on the median values. Which of these books takes longer to read? Or which of these books can we read more pages of, then I guess we would say. We would say version A, you can read more pages in 30 minutes. Can read more pages in 30 minutes. Because the median is 25 pages read versus the median for the second version is 23 pages read. So that one must be a little bit harder to read. Okay, next problem. Do this with me in your notes. This is example 1 for you in your notes. A biology student is studying 2 species of endangered parrots. What is the mean weight of each sample? Make a comparative inference based on the mean values. Now you should remember how to find the mean from our lesson yesterday. I want you to hit pause, find the mean for the macaw, and then find the mean for the cockapoo. I guess that's how you say that. And then we're going to make a comparative inference based on their means. So hit pause, work it out, get each of the means. You can use a calculator. When you're ready to compare them, hit play. Alright, remember the first thing we do to find the mean is we add up all the values in the data set. So I'm adding all of these numbers together. 2.9, 3.2. So I got the sum is 26. I divide by how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. So 26 divided by 8, I get that the mean is 3.25. What does that stand for? The mean weight. So the birds, the mean of the macaw, the weight would be 3.25. All right, now let's do the cockapoo. 3.9, 4.5, 5.3, 6.7, 7.4, 8.1, 6.4, 8.1. I'm seeing some bigger numbers in this data set, so my guess is it's going to be bigger. Alright, I get 50.4 when I add them together. And then I divide that by 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Divide by 8. And I get that the mean here is 6.3. So what is a comparative inference that I can make comparing these two data sets? Which of these birds is more likely to weigh more? The cockapoo, because the mean is like just about double what the macaw's weight is. All right, next example. Just look at this one with me. You don't have to look at it. You do have to look at it. You don't have to write it down. Hello. Okay. A biology student is studying 2 species of endangered parrots. What is the median wingspan of each sample? Make a comparative inference based on the median values. Again, from the box plot, where is the median value? We look inside the box at where the line is. That is our median. We read what the number would be. So, looking down, I would say that's 42 inches. Over here, looking down, I would say that's 33 inches. So comparing the wingspans, which bird is more likely to have a bigger wingspan? Based on the medians, it would be the macaw. Alright, they want us to find the mean of each sample here. Remember from the dot plot that each dot tells you how many times that number occurs in your data set. So first we want to list the numbers out and then find the mean of them. I do want you to do this with me in your notes. Okay, so first write down version A, and let's make a list of all the numbers. So 20, 20, 24, 24. They're going to have 5 25s, 3 26s, and 1 27. So I add them up in my calculator. Adding. And so the sum that I got was 293. Now what do I divide by? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by 12. And that gives me about 24.4. I'm rounding here. About 24.4. Okay? Alright, next. Version B, I first need to write my data set out. So I'm going to come up here, 22. We're going to have 3 of those. We're going to have 4 23s. We're going to have 2 24s. We're going to have a 25, a 26, a 27. So finding the mean, I first add those up. 23. 4, 25, 26, 27. So I got 284. How many numbers are in my data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again. And my mean is, oops, would we expect to be able to read more pages of? We would expect to be able to read more pages of version A based on the mean. The mean is slightly bigger. That means that we can read more pages of version A is our guess. Okay, if you have different comparative inferences based on each measure of center, you can draw a conclusion about the situation by looking more closely at the data sets. Sometimes we have a value that might do what we call skew. It might skew the data set because it's way bigger than the other values. Do you see how all of these are really close together? We would use the mean because there's not a skew number that would throw the mean off. But whenever you have one number that's either significantly bigger or significantly smaller, like a dot over here, we would want to use the median. Because if you think about it, when we do the mean, we add up all the values, divide by the number of numbers in our data set. If we're doing it that way, then a skew or a stray data value would throw it off. That's why we would have to use the median. Otherwise, if all the dots are pretty close together, we would want to use the mean. All right, here we see that the mean and the median have both been calculated. A book publisher is testing 2 versions of a new book. A random sample of 30 people is given 30 minutes to read each version using the data. What might the publisher conclude about the book versions? Well, as we look at the dots, what do we notice about version A and version B? Is the data all close together like this where we can use the mean? Or is the data kind of spread out like this where we would want to use the median? Look at them. Because of these guys over here, and we see some of them up here, the mean might be a little bit off. That's why we would want to use the median. Okay, so we would use the median. We would say, we would predict about 25 pages read in 30 minutes from version A, about 23 minutes or pages read from version B. And we do see that the mean and the median are pretty close together for these data sets. So it's not that thrown off, but just a little bit. Okay, copy this into your notes. No, we just did this. This is the same thing. Hello. Okay, last thing we need to look at is these bar graphs, because you will see a couple of these on digits. Look at this example. It says, a psychologist is studying how spending time outdoors affects people's moods. He surveys 2 samples of people chosen at random. What is the range of mood levels for each sample? Make a comparative inference about the populations based on range. Now, we haven't done a range one yet today, but we did it in the last lesson. How do I find the range? I am going to subtract the biggest number minus the smallest number. So we're looking at the range of mood levels. And they've used this kind of bar graph looking thing to do that. So I see what is the highest mood level and what is the lowest mood level for the outdoor group. The highest is at 10. The lowest is at 0. To find the range, we just subtract those. 10 minus 0 is 10. With the indoor group, what is the highest and the lowest? The highest is at 8. The lowest is at 0. So the range is 8. So what can we kind of make an inference about based on that? We can make an inference that with the outdoor group, their happiness or their mood level ranged more. So maybe some people love the outdoors, but some people hate the outdoors. Whereas with the indoor group, there wasn't anybody all the way at a 10. That means that people don't love being indoors as much as they love being outdoors. But there were still some people at 0 there. So more of a range of emotions with the outdoor group. All right, that's kind of the same thing. All right, at this point, I didn't change the way these directions are written. After you finish digit 16.3, you're just going to do the Unit 15 IXL assignment. Okay, so 16.3 goes with this lesson, and then the Unit 15 IXLs. Raise your hand if you need help. Show me your notes when you're done.